All right, so I'm just going to show you how to use right hand rule for three different situations, and I hope this will make your understanding clear of right hand rule. Now, when you have, let's say, generally, when you have a cross product like this, A is equal to B cross C, okay, and let's say B is right here and C is like that, right? So, in order to know what is the direction of A, you curl your fingers from B towards C of your right hand, and thumb points to the direction of A. Okay, that's with any cross product like this. So, this will be the direction of A. You can think of B being x axis, C being y axis, and A will be z axis, right? So the point is, when you have this equation like this, you curl your fingers from B to C and your thumb points to the direction of the A. Now what happens is, you have this formula where you have FB equals Q V cross B, okay? So this formula is same as this guy, okay? So that is the point. So when I use right hand rule here, what I'm thinking of is this thing where I need to curl my fingers from B to C, and in this case it will be from V to B, and the thumb will point to the direction of FB. So if you have a magnetic field like this, okay, this is the magnetic field, it's going into the board, okay, and this is some charge Q which is entering this magnetic field. That means it has velocity to the right direction. So I curl my fingers of right hand in the from direction of V, that is to the right, into the board will be this, and thumb will point to the direction of the force. Okay, so when I'm doing this, I'm thinking of this because I'm using the same formula, like a similar formula where this thing is equals to cross product of what's on the right, and that means FB is a cross product of V cross B times Q. So I do this V to the right. Cross B means curling my fingers from this direction to the right to the direction of into the board, and this gives me the direction of the force. That means if it's a positive particle, that is important, as soon as it will enter, it will do this. Okay, if this was negative, the opposite will happen, whatever is happening for the positive. If this was negative, then this would be the trajectory. You can also see this from here. This will be in minus of this. So in this situation, this is what I use. Okay, now there's another situation when you have a current like this and it has, let's say, some current I. Then what you do is you just point your thumb to the direction of current and you curl your fingers like that, and that gives you the magnetic field direction. If you want to be more technical and follow the norms, this side will be into the board, so magnetic field here will be like this and magnetic field here will be like that. Okay, so here in this situation, I take my thumb, point my thumb to the direction of the current, curl my fingers. So that is the direction of magnetic field, is going around the current wire like so, and circulating. Now in this equation, you have current here like that, right? So you do the exact same thing that you do here. You point your thumb to the direction of current and you curl your fingers like so. If you can imagine it, what is happening is there are like magnetic field lines which are going like this. Okay, that means if you can imagine it like curling your fingers like this means that in the circle, like inside the circle, magnetic field is going in like that, and out of the circle they're coming out to the board. So here it's like that all the way. Okay, so three, like these two are connected, but this is from the formula of cross product. So this is how you'd use right hand thumb rule for these three situations.